Okay, the final topic for Chapter 5 will be the magnetic fields of current loops, and we'll see how these are used for solenoid switches in particular. Solenoid switches are used for a variety of purposes. Anytime you want to make something physically happen without actually touching the thing, then you can use a solenoid switch. We use these in our cars, for example, in order to start our cars, to engage the switch to start our car. So it's a very useful thing and used in a lot of different applications. First of all, if we have a loop of wire, say we have a loop of wire that's like this, and we have a certain current flowing through it, so that here the current would flow in this direction and then out of the loop of wire, we can determine the direction of the magnetic field through the curl rule. We could just, just like we did last time, we'll just say we imagine this part. We let our thumb go in the direction of the current, and then our fingers wrap around. So on the top, the magnetic field would go into the page, and on the bottom it would go out of the page. And up here, if we let our thumb go in the direction of the current, on the bottom it goes into the page, and on the top out of the page. And so inside this coil you get a magnetic field that is into the page all around, and then outside of the coil you get a magnetic field that is out of the page all around it in that way. So by having this coil of wire, you generate these two magnetic fields, one that's into the page, one that's out of the page. We can also determine the magnitude. We're not going to go into deriving this, but this is how you find it. Mu naught I over 2r, where r here is the radius of the loop. So r is the distance from here to here. All right. If we have multiple turns of wire, as is often the case, we just multiply it by the number of turns of wire. So a coil of wire is used for various purposes. For example, in a solenoid is just a coil of wires. You put a current through it, it generates a magnetic field. I'll show you this video in just a second. Let me show you first what the solenoid looks like. Here it is. It's just a coil of wire. Oh, actually, I do have another video that I want to show you, first of all, going back up here. Sorry. So if you look at this, I have a video here. This is really just short animation. It's just about 20 or 30 seconds that shows how when you change the direction of the current, it changes the magnetic field. So you can watch it now. Now, for the solenoid switch, here we have this coil of wire. And in a solenoid switch, you would have this coil. And then inside the coil, you would have a magnet. All right. And then when you would turn on the current within the coil, it would interact with this magnet, either causing the magnet to move out of the coil or drawing the magnet back into the coil, depending upon how the poles of the magnet line up with the poles of the magnetic field generated by the coil of wire. So we have some nice applications for this. Solenoid switches, as I said, these are used in your car to start your car. So when you engage your key on your what's it called, the shifting column, steering column. When you engage the key, you turn on a switch, an electric switch. You turn on an electric switch, which puts current into this coil of wire here, and it causes a switch to engage the starter motor. So if you've ever dealt with the starter, you know that there's a solenoid on it. That's just a solenoid switch to turn the starter on. So I also have here a video about a solenoid valve, and this is a similar thing. It's using a solenoid to either turn on or off a water valve, and you can watch that here. All right, that's the end of Chapter 5, so make sure you do your homework, and we'll start up with Chapter 6 soon.